is in Zoom. Okay. Good morning, everybody. Today we are going to start chapter 2. Chapter 2, linear equations and inequalities in one variable. Firstly, what kind of equation is a linear equation? Let's look at the definition. A linear equation in one variable, here we use x to be the variable, is an equation that can be written in the form ax plus b equals 0. X is the variable, right? A and b are constants. They are coefficients. A is the coefficient of x. B is the constant term. A and b could be any real numbers. A cannot be 0. If A equals 0, then we don't have this part anymore. We don't have an equation with variable. So any equation which can be written in the form ax plus b equals 0 is a linear equation in one variable. That's the formal definition. I have a very useful trick that can help us to determine if an equation, linear equation in one variable or not. Very useful, very convenient. So I have the 3 conditions here. If the expression has equal sign, means it is an equation, right? So that's the first condition. The expression contains equal sign. Second condition, the equation only has one variable. Third condition, the exponent on the shoulder of the variable is 1. You will not see x to the power of 2 or x to the power of -1. So if you see variable x appears, the exponent on the shoulder of x always be 1. If all the 3 conditions are satisfied, then the equation is a linear equation in one variable. Linear. Linear means one dimension, okay? One dimension. So the exponent on the shoulder of the variable must be 1. Am I clear about that? So we are, this section, the focus is to solve linear equation in one variable, right? So we're gonna know what kind of equation is a linear equation in one variable. To determine, we look at the 3 things. It's an equation, it has only one variable. The exponent on the variable is 1. So if those 3 conditions are satisfied, then the equation is a linear equation in one variable, okay? Yeah. It's more useful than the definition. It's more useful than the definition to determine if an equation, linear equation in one variable or not. Am I clear about that? For example, yeah, I think the best way to determine is to look at equations. Number 1, 2x equals 1. Let's check the 3 conditions we have just seen. Equation, right? You see equal sign. One variable only, right? Yeah. And what's the exponent on the shoulder of variable x? Yeah. So this is a linear equation in one variable. Yeah. I hope I have your attention. Okay. Am I having you? Are you paying attention? Yeah. Oh, you're having your notes on your phone. Okay. Number 2, look at this expression. This is an equation. One variable only. The exponent on the shoulder of variable x is 1, right? Number 3, equation, one variable. You see x appears twice, but that's only one variable, right? And wherever x appears, the exponent on the shoulder of x is 1. So those equations are all linear equations in one variable. What if I change x as y, would that still be a linear equation in one variable? Could we use y to be the variable in the linear equation in one variable? That is okay, okay? Yeah, doesn't matter the letter. Same thing if I change the x here as t. It's still one variable, okay? Yeah, as long as it only contains one variable. If we have here x, here is y. X and y are seen as two different variables. Then the equation is not a linear equation in one variable anymore, because obviously it has two variables, right? Does that make sense? What if here we have 2x squared equals 1? Would that equate a linear equation in one variable? Not anymore, okay? This is quadratic. Yeah. To be linear equation in one variable, the exponent on the shoulder of x has to be 1. Does that make sense? Okay, very good. Again, the focus of today is to see how do we solve a linear equation in one variable. Solving a linear equation in one variable is the process to find the solution or solutions for the equation. Now, how do we define a solution of a linear equation in one variable? Let's look at the definition here. On the top, a solution of an equation is a number that makes the equation true when it replaces the variable. So it means if we plug in the value, if we substitute the value for the variable, then the equation is a true statement. In other words, if the value satisfies the equation, it means we plug in, we get a true statement. Then the value is a solution. Otherwise, if we plug in, we got a contradiction, then the value is not a solution. Does that make sense? Does that make sense? Yeah. A solution of an equation is a value. If you substitute the value for the variable, then the equation is a true statement. It's a true statement. Means the value satisfies the equation. Okay. So solving an equation is the process of finding all the solutions for a given equation. Let's see here. Example 1, we have 3 examples. Those 3 examples, those 3 equations are all linear equations in one variable. Because you can see equation, one variable, exponent on the shoulder of variable is 1, right? And they all have the actually the same pattern. Variable x plus a number equals another number. Yeah. They are all same pattern. Let's see, how do we solve this type of equation? Number 1, the equation is x minus 1 equals 7. We are going to apply the addition property of equality. Addition property of equality. So we are going to apply addition property of equality. And what is addition property of equality? For example, if you have a scale, I think maybe if you go to pharmacy, I don't know if the pharmacy here has the scale. Well, in my culture, the pharmacy always have the scale to weigh things. So this is the left hand side, this is the right hand side, right? You see something like that, a scale. Yeah. So if you put 5 pounds on the left, in order to keep the balance of the scale, you have to put 5 pounds on the right as well, right? Does that make sense? Yeah? Lauren, does that make sense? If you remove 1 pound from the left, you have to do the same thing to the right in order to keep the balance of the scale, right? Okay. Yeah? Yeah, that's the addition property of equality. Equation is like a scale. Equation has a left-hand side, has a right-hand side. Whatever stuff to the left of the equal sign, that's the left-hand side. Whatever on the right, to the right of the equal sign, that's the right-hand side. So addition property of equality means for an equation, if you add a number to the left and you add the same number to the right, in other words, if you add the same number to both sides, the equation still holds. The scale still keeps the balance. Same thing, if you remove means subtract, right? Yeah. If you subtract or minus a certain amount or a number from both left-hand side and right-hand side, then the equation still holds. You know, the balance of the scale is still okay. Does that make sense? It's very, straightforward, right? Yeah, okay. So that's the addition property of equality. When we solve a linear equation in one variable, whenever you solve a linear equation in one variable, you need to know your goal. I'm going to write a goal in the red bubble, is to isolate x on the left. Okay. Well, if you isolate on the right, it's also okay, but by convention, we also always isolate the variable on the left. Okay. Again, I'm gonna do this often. Whenever you solve a linear equation in one variable, you need to know my goal, your goal is to isolate x on the left. It's like whenever you sit in your car, you are going to drive, you need to have a destination in your head, right? Or GPS set up. This is a GPS. So whenever you're going to solve an equation, this is your goal. Isolate x on the left. Okay. Let's see what's on the left in this equation. We have x minus 1. How many terms do you see in this equation? In the left-hand side of the equation. Terms. We learn what is term, right? We learned term the last section of chapter 1. How many terms? Terms are separated by plus or minus, right? How many terms on the left? 2 terms. One is x, the other is negative 1, right? So it means x is not isolated yet on the left-hand side. We need to get rid of the term negative 1, right? How do we get rid of the negative 1? What's the opposite of negative 1? Positive 1, yeah. So we're going to do is we're going to add 1 to both sides of the equation. We can do this because of addition property of equality. Okay, yeah, we add 1 pound on the left, add 1 pound on the right. So the equation still holds. The scale still balanced. Negative 1, positive 1, they cancel each other. Do you see that? That's how you isolate the x on the left, right? Now x is isolated on the left. What is on the right? 7 plus 1. It was 7, but you add 1 more, right? Do you have 8? Yeah? Okay. And that's the solution. Yeah. Once you isolate the x on the left, the number on the right, which equates the variable, that's the solution you're looking for. Okay? Yeah, we can double check. Let's say we have the number 8, right? Let's plug in. Yeah, let's replace the variable with the 8, or substitute the 8 for variable x. We plug in here, we put the 8 here. 8 minus 1 equals 7. True statement or false statement? 8 minus 1 equals 7. Obviously it's true, right? So that means the solution we found is the correct solution. Does that make sense? Am I clear? Okay, again, when you start to solve a linear equation in one variable, how do you get it started? You need to know your goal is to isolate the x on the left. Yeah, if the variable is y, then isolate the y on the left. Yeah, when you work on your math assignment, maybe the letters T or W, you just isolate the variable on the left. Okay. Let's continue. Number 2. We have x plus 1 over 5 equals 21. We are going to solve the equation. So what's the goal? We're going to solve the linear equation in one variable. So we are going to what? Yeah, isolate x on the left. Okay, what's on the left right now? On the left, we have x plus 1 over 5. X is not by itself on the left, right? Yeah. So we need to get rid of 1 over 5. How do we get rid of 1 over 5? You see this operation is adding, right? So it means we have 1 over 5 extra on the left. We don't want that. So we're going to remove it, right? Then do we minus? Yeah. So minus 1 over 5 or negative 1 over 5 is the opposite of 1 over 5. So that's what we're going to do. We're going to minus 1 over 5 from both sides. And they cancel, right? And we have x isolated on the left. On the right, we have 21 minus 1 over 5. Okay, your turn. I know, these are fractions. You're gonna tell me what is 21 minus 1 over 5. Yeah, 21, we can write 21 as 21 over 1, right? That's what you mean? Very good, yeah, minus 1 over 5. So that's a difference of two fractions. Do we need at least a common denominator when we minus two fractions without the same denominators? Yes, this is the 1, this is the 5, right? What's LCD? What is LCD? Least common denominator. What's the least common multiple of 1 and 5? 5. Special case number 1, right? 1 and 5, 5 is the multiple of 1. LCM is the bigger number, okay? Yeah, I'll give you 1 minute. Let's see if anyone could get the answer as a fraction. Well, the test 1, most of us have done pretty well. Yeah, I mean more than half, more than 50%. Oh, that's good enough, but I think you guys can do better. For example, what's the smallest prime number? 2, yeah. How could you guys choose the wrong answer again? Because I have repeated so many times. The smallest prime number is 2, right? The smallest whole number is 0. So you see, I do not challenging you. If you paid attention in the class, the important thing I repeat over and over and over. And the review problems are so similar with the actual problem on the test. So if you ever paid attention, you should all get an A. This is intro algebra, right? Yeah, you wanna like an A on your transcript. You don't want a C or D. That doesn't look very well. Okay, what is 21 over 1 minus 1 over 5? Huh? Lauren, do you have the answer? Perfect, exactly, that's correct, yeah. So the first fraction, 21 over 1, if we multiply both top and bottom by 5, then the first fraction becomes 105, because 21 times 5 is 105, right? Yeah, over 5 minus 1 over 5. When the two fractions have the same denominators, the rule is, remember the rule, keep the bottom, solve the top, reduce the result. So you keep the bottom, solve the top, we have a 104 over 5. How do we reduce it? Since the 104 is not divisible by 5, the two numbers, the numerator and the denominators are mutually prime. So this is already reduced. You don't have to convert it to mixed number. I don't require that, okay? Yeah, you can have the answer as improper fraction. As long as the fraction is reduced, that'll be okay. Good job. That is 104 over 5. Yeah. So that's how do we solve number 2. It's also isolate the x on the left, right? We also applied the addition property of equality. Number 3. You see the 3 problems, 3 examples, the 3 equations, although they have a similar same pattern, but this one is a whole number, number 2 fraction, number 3 decimals. So we're gonna apply all of them. Number 3, x minus 0.2 equals 0.7. Good news, you know what is the good news? Because after test 1, you are able to use a calculator for the test, right? So you don't have to worry about the calculation part. we are going to solve x minus 0.2 equals 0.7. What's the goal? Yeah, isolate the x on the left. Isolate x on the left. Okay. Let's see what's on the left right now. Two terms, right? X and negative 0.2. How do we get rid of a negative 0.2? Yeah, plus 0.2, right? We're gonna do the same thing to both sides of the equation. Knowing is a scale. If you only do the thing, if you only apply the treatment on one side, the scale will lose its balance, right? So it means whatever you do on the left, you're gonna do the same thing on the right. Then the scale can keep the balance. Okay, left hand side, negative 0.2, positive 0.2 cancel each other. So we have the x isolated on the left. What's on the right? I think you don't have to use calculator for this. What is the 0.7 plus 0.2? Adding. Oh. Adding. We are, yeah, 0.7 plus 0.2, okay? Yeah, adding. 0.9, very good. 0.9, okay? So basically, you just add the opposites of the number you want to get rid of to both sides of the equation to isolate the x. In this example, right? All the three equations are same pattern. So first again, too easy? Yeah, okay. We're gonna see some other, second example would be a little bit more complicated. And this example, all the three equations are same pattern. They are the same pattern, okay? Yeah. Through this example, we are going to learn the multiplicative property of equality, okay? Multiplicative property of equality. What does that mean? Yeah, let me use the scale as the example again. This is the scale, left hand side, right hand side. Huh? Oh, that's not very balanced. I mean, okay. So this is the scale, right? It doesn't look pretty though. So this is scale. So let's say if you have 5 pounds on the left, you have 5 pounds on the right. So the scale is balanced, right? Right? Okay. So now I want to double. I want to double the left hand side. Multiply by 2, double it. So I have 10 pounds here, right? In order to keep the balance, do I also need to double the right hand side? Multiply by 2. Yeah? Yes or no? Yeah, so if I if I multiply the left hand side by a certain number, and I do the same thing on the right hand side, multiply the weight on the right hand side by a certain number, the scale still keeps the balance. It's very straightforward, like common sense. Same idea. Let's say if I have 3 pounds here, 3 pounds here, right? If I divide the left hand side by 3, I have 1 pound, right? In order to keep the balance, I should divide the right hand side by 3 as well, in order to keep the scale in balance. Does that make sense? Yeah. So here means left hand side, right hand side. If I apply the same treatment, means multiply the same non-zero number or divide both sides by the same non-zero number. We don't count a 0, okay? If we multiply 0, everything would become 0. That doesn't work. Yeah. So if I multiply both sides by the same non-zero quantity or divide both sides by the same non-zero quantity, the equation still holds. Okay? Yeah, same treatment. Multiply or divide also work. Let's see how do we solve those three equations. Then in example 2. Number 1, 2x equals 93. Okay. What is the thing? If I draw a bubble, I'm going to write something in the bubble. What do you think I'm going to write? Yeah, isolate x on the left. Always like that, okay? And whenever you're going to solve the equation for x, You know, my goal is to isolate x on the left. Let's see the left-hand side. What is on the left right now? 2x. We don't want a 2, right? We want an x. We don't want a 2. So how do we get rid of the 2 here? Could we minus 2 from both sides to get rid of 2? Why not? Why it doesn't work this time? Yeah, you are right. Because the connection between the 2 and the x is a multiplication, right? It's twice of x. In order to get rid of the twice, we have to cut it in half, divided by 2, right? Awesome, that's correct. So again, we're going to do the same thing to both sides. We are going to divide both sides of the equation by 2. 2 over 2 is 1, right? Yeah, 1 times x is x. So isolate x on the left if the coefficient 2 is the coefficient of the x, right? Yeah. So when we want to isolate the x, we want to change the coefficient to 1. Yeah, if it's not a 1, then we have to divide both sides by the coefficient itself. Here we divide both sides by 2. Does that make sense? So once the coefficient is 1, x is isolated in this case. On the right-hand side, we have a negative 3/2. Here we go. That's the solution. Is that doable? Pretty straightforward, right? Yeah, I believe everybody can do that. Very simple thing. Any questions so far? Number 2. Negative 2 over 3x equals 7. Okay, so we are solving this equation. Then what is the goal? What's the goal? You see, I move the bubble down. We are trying to what? Isolate the x on the left, okay? What's on the left right now? We have a negative 2/3 x. Yeah, that's what we have on the left right now. What's the coefficient of x, by the way? What's the coefficient of x, by the way? Negative 2 over 3 is a fraction, right? It's a fraction. Of course, if you divide both sides by the coefficient, of course, you will have the solution. But more convenient way, so I want you guys to write this down. More convenient way, when the coefficient of x is a fraction, instead of dividing, you want to multiply both sides by the reciprocal of the coefficient. Can you please write it down? Yeah, everybody? Yeah. We want to isolate the x, right? When the coefficient of x is a fraction, it's not a whole number or decimal, it's a fraction. Instead of dividing, we want to multiply each side of the equation by the reciprocal of the coefficient of x. Yeah, I think the English is pretty clear. Even English, not my first language, I think it's clear logically. If the coefficient of x is a fraction, right? Then you multiply both sides by the reciprocal of the coefficient of x. Let me know when you finish the copy. You done? I'm going to show you why this is more convenient. Yeah, why don't we divide instead of we multiply the reciprocal, okay? All right, let's see. As we see, the coefficient is a negative 2 over 3, right? Coefficient is a negative 2 over 3. Yeah, coefficient is a negative 2 over 3. What's the reciprocal? What's the reciprocal? Positive? Negative, yeah. Negative 3 over 2, very good. We learned this, right? Reciprocal is the multiplicative inverse. We learned this last chapter, right? Yeah, reciprocal. The sign does not change. If it's a negative, the reciprocal is still negative. All you need to do is to interchange the top and the bottom. So the negative 3 over 2. So we are going to, so this is the equation, okay? We are going to multiply each side. Yeah, multiply each side by the reciprocal. Yeah, the reciprocal is a negative 3/2. Negative 3/2. Negative 3/2. Okay, is that clear? Yeah, we found the reciprocal is negative 3/2. We multiply each side of the equation by negative 3/2. Okay, let's see what happened here. On the left-hand side now, we are going to use the associated property we learned from last chapter. Associated property. See here. 1, 2, 3. 3 quantities, right? Right now, the negative 2/3 and x are associated, correct? Yeah, we can like disconnect them, not disconnect them. We can like associate negative 3/2, negative 3/2, and the negative 2/3, and then multiply x. Associated property. Instead of we have those two numbers multiplied together first, we multiply negative 3/2 and the negative 2/3 together. That's associated property, right? And tell me what's the value of the green part? Huh? 1, yeah. Yeah, the multiplication of two numbers whose are reciprocal of each other is 1, right? Does that make sense? It's not 0, okay? It's not 0, it's 1. Okay, so we have 1 times x. But that's how x is isolated. On the right-hand side, we have 7 times. Again, by the way, this is another 7 minus 3/2, okay? This is 7 times negative 3/2. We determine the sign first. Positive times negative. Do you have a positive or negative? So you put a sign here first. And then you have a 7 times 3/2. Yeah, why do we learn operations with fractions in chapter 1? We did spend a lot of time about the fractions. That's the reason, because it's not avoidable to handle fractions. I give you 1 minute and tell me what is 7 times 3/2. What is 7 times 3/2? Multiply two fractions. Where is the door? What did she leave? Did you see her? The girl in the back. The back? What is 7 times 3/2? How about we write 7 as 7/1? What is the rule when you multiply two fractions? What is my rule? Vertical, vertical, diagonal, diagonal, and multiply cross, right? So in this case, you can see vertical, nothing, vertical, nothing, diagonal, nothing, diagonal, nothing. So you can just multiply cross. What is 7 times 3? So your answer is negative 21/2. Am I clear? Yeah, knowing how to do it and practice. Because sometimes you know how to do it, it doesn't mean you can do it correctly. It takes practice. That's the second problem. It's very important. If the coefficient of x is a fraction, you don't want to divide, okay? You want to multiply each side by the reciprocal of x. Yeah, let me show you why you don't want to divide. Because you have a negative 2/3x equals 7, right? Okay, the coefficient is negative 2/3. So you know, okay, I'm going to divide both sides by negative 2/3. Negative 2/3. And then you have x equals 7 divided by negative 2/3. And then you have to flip, right? Of course, you end up the same thing. But for some students, it's easier for them to mess it up when they divide. So I would say multiply is better. Of course, if you want to divide, that's totally okay, okay? Am I clear? But it is more convenient if you multiply the reciprocal instead, okay? All right, last one, number 3. Next one. Number 3, 0.2x equals 0.8. We are solving this linear equation in one variable. If I draw a bubble, what do you think I'm gonna write in the bubble? Huh? What did I do earlier in the bubble? Isolate x on the left, okay? Always like that, no matter how complicated it is. 0.2x. Yeah, we must have a variable, right? We must have a variable. 0.2 times x. It is harder for me, this position to write. 0.2 times x equals 0.8. What's on the left right now? One term, 0.2x. What's the coefficient of x? 0.2, right? Yeah. So how do we get rid of the coefficient? How do we get rid of the coefficient? We're going to plus, minus, multiply, divide. Divide, awesome. We're going to divide both sides by the coefficient itself, right? And they cancel. I mean, 1 over 1. 0.2 over 0.2 is 1. We have an x isolated on the left. What is 0.8 over 0.2? Tell me what is 0.8 over 0.2? Okay, think about this is 8 dimes or 80 cents. This is 20 cents. Yeah, how many times 0.8? I mean 80 cents towards 20 cents. You don't have a 0.4. You have 4. 8 dimes is 4 times 2 dimes, right? The dimes, the small thing, small coin. So you have 4. Another way, well, you have a calculator, but I still think you should learn. So you see the decimal point? If you move the decimal point to the right one time, and you do the same thing to the denominator, then you would have 8 over 2, right? Bless you, correct? And 8 over 2, you know it's 4. Better? So you can apply the same treatment to both numerator and denominator without changing the value of the fraction. Yeah, you move the numerator, the decimal point in the numerator to the right one time. You do the same thing to the denominator, and the fraction still holds, still the same value with the original. That's number 4. So x equals 4 here. All right, x equals 4 here. That's the first section of this chapter. We learned the 2 properties. I explained the 2 properties by using scales as the example, right? So if you have a scale like an equation, left-hand side and right-hand side, if you plus or minus the same amount to both sides, the equation still holds. Yeah, the second property, if you multiply the same non-zero quantity or divide the same non-zero quantity, the equation still holds, right? So that's the 2 properties we learned to solve linear equation in one variables. Very important, you know, when you start a solution, you know, okay, my goal is to isolate x on the left, whatever I do, and that's the goal. Let's move to the next section. Oh, that actually is a 2.1, 2.2. Yeah, so now I put them together. So now we're gonna see 2.3 and then 2.4. Like a more complicated equation, linear equation in one variables. Okay, so let's see. So when you work on your MATLAB math, we done 2.1, 2.2, yes? Yeah, please. Okay, so in this section, we are going to see how do we solve linear equation in one variables, which are more complicated. Yeah, more complicated. Let's see the first example, solve for x. Number 1, 3x minus 2 equals 5x minus 8. Before we process the equation, how about let's read the guideline here. Solving a linear equation in one variable, we have the following 4 steps, okay? It gives you a guideline. Step 1, simplify each side separately. Use the distributive property as needed. Clear any parentheses. Combine like terms. So the first thing, because equation has 2 sides, right? Left-hand side and right-hand side. If you can simplify each side separately, then you're going to do that first. Step 2, isolate x. Yeah, isolate the variable term. I'm going to show you what is the variable terms, okay? Yeah, let me highlight it, this concept, variable terms. I'm going to explain what is the variable terms. Isolate variable terms on one side. Normally, we isolate the variable terms on the left. Use the addition property of equality so that all terms with variables are on one side of the equation and all constants are on the other side. So variable terms and constant terms. Step 3, isolate variable x. You can use the multiplicative property if needed. Step 4, check. Substitute the value found into the original equation. If a true statement results, write the solution set. If not, rework the problem. Technically, step 4 is not mandatory, but it's always good if you apply it. It's always good if you apply it. Okay, let's see, how do we apply the guideline to solve a linear equation in one variable? This problem. 3x minus 2 equals 5x minus 8. Equation, one variable, linear, right? Okay. So what's the first step that I showed you earlier? It's more complicated. Simplify each side separately, right? Let's see the left-hand side, 3x minus 2. In 3x minus 2 already simplified. 2 terms, right? We don't have a parenthesis to erase or to remove. We don't have like terms to combine, right? It's already simplified. Right-hand side, the same thing, already simplified. I want you to see the structure. I think I have emphasized this many times. For expression or equation, see the structure is super important. For this structure, how many terms in total do we have? How many terms in total do we have? Terms. How many terms do we have in total? Terms are parts separated by plus or minus or equal sign. Yeah, how many terms do we have? How many terms on the left? 2, yeah. How many terms on the right? 2, so together we have 4 terms, do you agree? Yeah, exactly. All right, see here. The two green terms, they are variable terms. We see this word earlier, variable terms, because they have a variable x in it, right? So those two terms in green, they are variable terms. The two purples, they are constants. Very obvious, right? Okay. So what we want to do is we want the two greens on the left, the two purples on the right. How could we do that? How do we get rid of 5x in green from the right-hand side? How do we get rid of that from right-hand side? So I'm going to show you two different methods, okay? Solution, the first method. We use the property we learned earlier, yeah. In order to get rid of 5x from the right-hand side, then I just minus 5x from the right-hand side, right? But I have to do the same thing to the left because the scale needs to keep balance. Does that make sense? Okay, let's see what happened after this. Do they cancel each other? The equal sign is like an anchor. You're gonna bring it down all the time. Yeah, you bring it down. So on the right-hand side, you only have a -8 right now, right? Because the 5x and the -5x cancel each other, add up to 0. The left-hand side, what is 3x minus 5x? -2x, very good. -2x, you still have -2 on the left, so you're gonna bring it down. That's how do you get rid of 5x from the right-hand side. And now do we need to get rid of the -2 from the left-hand side? Because remember, we don't want the constant term on the left. We want the constants on the right-hand side, right? How do we get rid of this -2 from the left? Huh? +2. Very good. You're going to add a 2 to each side. -2, +2, add up to 0, right? So the left, we have -2x. On the right, what is -8 plus 2? -6, right? Correct? Yeah, one more step to isolate x. Of course, the goal is still isolate x on the left. But it takes more steps than the examples we see in earlier section. We are not done yet. X is not isolated yet. So how do we isolate x? Divided by what? Perfect, -2. Cancel, cancel. We have 1. X is isolated on the right. What is it? -6 divided by -2? +3. Awesome. Right? So from the guideline, the last step is better. You can check your result. As I said, checking part is not a mandatory, but it's good if you can apply it. Yeah. Let's see. X equals 3. And the equation is 3x minus 2 equals 5x minus 8. If we plug in x equals 3, yeah, if we plug in x equals 3, let's plug in. So 3 times 3, 5 times 3. 3 times 3, tell me what is it? 9, right? Not 6. 3 times 3 is 9. What is 5 times 3? What is 9 minus 2? What is 15 minus 8? Do you have a true statement? Yes? 7 equals 7 is a true statement, right? Yeah, that means the solution you found, number 3, is the solution of the original equation. All right? It's always good you check, even technically it's not mandatory. It's good if you can always check it, especially as a beginner. All right, let's make a summary here. Firstly, we look at the structure of the equation. We identify the variable parts, variable terms, and the constant terms, right? Yeah, we know we need to put all the variable terms on the left-hand side, all the constant on the right-hand side, right? Yeah, and then we combine them. And then we, how did we do that? In the first method, we use the addition property of equality to get that done. Another method, I don't know if you like it, I hope you like it, okay? Now I'm gonna show you another method to do the same problem, to process the same problem. And you're gonna tell me, do you like it or not? So this is method 1, method 2. 3x minus 2 equals 5x minus 8. Okay. Always observe the equation, knowing how many terms in the equation. Yeah, which of them are variable terms, which of them are constant terms. Yeah. So here, blue. So we have 4 terms. Let me color them differently, okay? Blue, purple, this purple, green, and orange. Yeah, 4 terms. This equal sign, as I said, is like an anchor. It stays there, okay? It's always there. You don't move that. Yeah, the anchor is always here, here, for each step, okay? Yeah, that's the left-hand side, whatever to the left of the equal sign, right-hand side, whatever to the right of the equal sign. Okay. Our purpose here, do we want the blue and the green together on the left? Tell me. Do you want the blue and the green on the left together? Do you want the purple and the orange together on the right? Right, we want that, right? Okay, let me show you a very convenient and useful way. I always try to set it in the class. Let me know if you like it. It's very convenient, okay? So we want a green term on the left, okay? We can do that. We can move it. The blue term stays, right? Nothing changes to the blue term. The green term, we want to the left. Right now it's to the right. What's the sign of the green term? Positive, right? Yeah. So we're gonna move it and we change the sign. All we need to do is we move it. We want a green to the left-hand side, we move it. But at the same time, we change the sign to the opposite sign. It was positive on the right. Now it is negative on the left. That's all it takes. On the right-hand side, the orange term, -8 doesn't change, okay? Do we want a purple move to the right-hand side? Do we want to move purple to the right-hand side? Right? Yeah. What's the sign of the purple? What's the sign of, yeah, negative, but yeah, so when you move it, you just change it to positive, and that's all it takes. Very convenient. The technique is called the transpositions of terms. Doesn't matter. You can move them around. Yeah, transposition of terms. How do you apply the technique? You move it and you change the sign. Okay, let me explain again. Very convenient. Especially this is each algebra, right? So if every single time you plus and you draw a line, minus you draw a line, that's very complicated. But in each algebra, because the equations are simple, it is still okay. But if you have a chance to go higher level mathematics, that method looks like too primal. How do I say that? Not very convenient, yeah. So you want to use my method. My method is very convenient. As I mentioned earlier, we have 4 terms, right? Blue and green, variable terms. Purple and orange, constants. We want the blue and the green on the left, purple and the orange on the right. So we can just move them around, right? All you need to do is to move them but at the same time change the sign to the opposite. Do you think you can do that? I believe if you can drive a car, you can do this. Driving a car is more multitask than this. There's only two steps, two things in one. Move it and change the sign, right? So you see, you move 5x. You move 5x over, positive becomes negative. You move -2 over, negative becomes positive. That's all it takes. So what do you think? Do you like this method? We'll try, okay? I think this is a good method to grasp. Why did we do that? Why did we move them around? We did that to collect like terms. Yeah, so we apply the transposition of terms to collect like terms. You see those two terms, blue and green, are they like terms? Purple and orange, are they like terms? Yeah, we collect them. Yeah. Like terms cannot be combined if they are on different sides of the equation. We could only combine like terms when they are on the same side of the equation, right? So now we can combine them. You guys tell me, how do we combine them? 3x minus 5x. 3x minus 5x. You tell me. Perfect, thank you. -2x. Do you agree, everyone? Okay, right hand side, -8 plus 2. -6, very good. Step to isolate the x, right? How do we isolate the x? How do we get rid of the coefficient -2? Divide. We have x equals 3. Okay? Two methods. I showed you two methods. The second method is called a transposition of terms. Very useful and convenient. Yeah, every time I try very hard to sell it. Your turn. I'm gonna give you a problem to practice. Number 2. The equation is 5x plus 2 equals 3x minus 6. Yeah, because I introduced the two methods, right? You can use the first method. Yeah, I'm happy if you try the second method. I'll give you a few minutes on this. Please copy it down. 5x plus 2 equals 3x minus 6. Very similar with the first example, first problem, the one we just done, the one we just did. You guys see the structure, right? So I'm going to give you a few minutes. You try it on your own. Yeah. 5x plus 2 equals 3x minus 6. You got it? How about? It was on the right hand side. How is going down? It was still negative. It was still negative. Yeah, 2 gonna be changed to negative. Because when you move it to the right, you have to change the sign. But -6 will be still negative. You mess up this the constant of the sign. So, yeah. It's the left hand side, it's the right hand side, right? So -6 already a constant. It's gonna stay on the right, right? You can change it. So -6. But 2 is on the left. You move it to the right. So 2 has to change. -6 and 2 becomes negative. So you have negative. Only you change the sign. So when you have your answer, how do you know you this is very close. And what is -6 minus 2? You go in. That's 6 units. And 8, right? Then you 8 divided by 2. And how do you know if you have a proposal solution? How do you know it's correct? You can plug in. Right? Very close. Very close. Do you have an answer? Ian, do you have an answer? So you move this over, right? Remember, you move it and change the sign. You move 3x over, you will have to change the sign. Negative. Yeah. How long you do this? How long? And you have -6 on the right. No, you don't have the variable part on the right. So you are not dealing with an expression. You are solving an equation. So you have the scale. You move this guy to the left. On the right, you still have -6. You bring it down. And you want to move 2 to the right. So you're going to have -2 on the right, right? Is that very confusing? I think it's pretty straightforward. You know the answer, right? Okay, you are good? What's the answer? Perfect. All right, guys. Let's process this together. Okay. I appreciate that you want to try my method. I appreciate that. Yeah, let's go slow, okay? Let me show you one more time. Do you remember I said this equal sign is like an anchor, right? You don't change it. Yeah, it's the scale. It's gonna be the scale, the middle part of the scale. All right? Yeah. So on the left, you have a 5x. 5x pound. I don't know what is that. So you have a 5x pound already, right? Now you're gonna move the 3x. You want to move 3x over, correct? Remember, you move it and change the sign. It is a positive, right? You move it, you change the sign. What do you have? Do you have a -3x? Yes or no? You see the anchor is still there, right? And then -6. Just to bring it down, because you have a -6 pound on the right. It didn't change nothing to that part. That part doesn't change it at all. You just bring it down. And for this 2, you want to move it over to the right-hand side, right? So it was positive. You move it, you change the sign. You have a -2. Do you see that? It's a very simple process. So I wish I could like move them. How about let me try? Could I move them like that? So you want to move this guy, right? Yeah, you can move it to the left. But when you move it to the left, you have changed the sign to negative. You see what I'm talking about? And then when you want to move 2 to the right, so you're going to change. Okay, hold on. Let me try this. 5x plus 2 equals 3x minus 6. So we want to move this guy to the left, right? Okay, you can move it, not a problem. But when you move it to the left, you need to change the sign to the opposite. Ian, do you see that? Do you see what I just did? And you want to move this guy to, oops. Let me do that again. So you want to move, this 2 to the right-hand side, right? Yeah, you can do that. Oops, let me do it again. You want to move it to the right-hand side, right? Just do it. But change the sign to the opposite. Yeah, remember to change the sign to the opposite. It was a positive, now it's negative. Do you see what happened? Simply, you just move them around. Does that make sense? Better? Yeah. So on the left, you see you have a -3x, positive 5x. You have 2x, right? On the right, you have -2, -6. That is -8, right? I think you can do the rest. Do you see what happened? All you need to do is move them around. Totally okay. It's like you have a scale, right? You have something on the left, you have something on the right. You can move them around. You can switch the sides. But whenever you move a term from one side to the other side, you need to change the sign to the opposite. That's all it takes. Okay? The answer is -4. Make sure you know that. And you know, all my problems on the test are multiple choice question, right? Suppose you have something like that in the test, and you have A, B, C, D, right? For example, A is 4, B is 0, C is let's say 2, D is -4. Worst case, the last resort. I'm just saying the last resort. You really don't know how to solve it, or you are not sure if your solution, the correct solution. What do? You check your result, okay? You plug in. Let's say A is 4, right? You plug in here. 4. 5 times 4. What is 5 times 4? 20. 20 plus 2. 22. So left hand side is 22. Right hand side, 3 times 4, 12, right? 12 minus 6. 6. 22 equals 6. Is that true statement or contradiction? Yeah, so you do not choose A. See that? That's how you know, okay? If you're lucky, the first one might satisfy already, then you are done. You got the correct answer. If you're not lucky like this one, you try all of them and last one satisfies, you choose the last one. Do you see what I'm talking about? So the second number is 0. Let's plug in 0 here, 0. So on the left we have 2, on the right we have -6. Doesn't work, right? Yeah, so you try 2, you plug in here 12, here you have 0, it doesn't work. So only this one works. Do you see what I'm talking about? There's no reason when you take the test 2, if the problem is solving equation, there's no reason you don't get it right when you have a calculator. All you need to do is try which number satisfies the equation, right? Of course, I want you to learn how to solve an equation because that's so basic and important. I want you to try another one. We did the number 2, right? Yeah. So we have 3 more minutes. I want you to try number 3. It is 4 times x minus 2 equals 2 times parentheses 2x minus 4. Oh, we have a parenthesis in this case. What does the guideline say if you have a parenthesis? Yeah, you distribute. Yeah, you're gonna simplify each side first. You're gonna simplify each side first. Distributive property. We learned this property last chapter. Very good. That's correct on the left. That's correct on the right. Also, very good. Distributive property. That's very good. Distributive property. 2 times 2x plus 2 times negative 4. Yeah, exactly. 2 times negative 4. 2 times negative 4. Twice of 2. Twice of 2. Yeah. By the way, if you need my help, you can make an appointment and drop by my office. You can ask questions. You're welcome, okay? I have office hours. And or you can go to student success center to get help. If you don't understand something in the class, please don't just leave it. Don't wait. It won't solve it by itself. Ask me, okay? I'll see you in my office. We get it done. Get it fixed. Look at this problem. Left-hand side, if we apply the distributive property, look at it here. 4 times x plus 4 times negative 2, right? Correct? That is 4x minus 8, correct? That's the right-hand side. That's the left-hand side. On the right-hand side, we have 2 times 2x plus 2 times negative 4. That is 4x minus 8 as well, right? 2 times 2x is 4x. 2 times negative 4, that's negative 8, right? Okay, so what's the solution of this equation? I'm going to tell you tomorrow. Yeah. Thank you guys for coming. I'll see you tomorrow.